and how we can use this program and to make it work properly. First step, let me close my view of the project. First step, let's build it, right? So we just say build. And right here, it begins to complain. I'm pretty impressed that the complaint isn't like anywhere earlier in this crazy program, but is actually as far as this. And the complaint is, if we go to view and display logs, right, it says that invalid type int for array subscript. Okay, so compiler understands this as something that I'm trying to use, and it disagrees with me. What needs to happen is this. We have to say that, we have to tell, the problem is this. We have to tell the compiler that besides we're trying to access memory at this specific base address, which is just 0, right? We said memory is 0. Memory begins at 0. And besides saying that we want to go this far and hoping to find our character in computer memory, we need to specify that this offset, if I take this expression and go back and paste it somewhere here. Okay, so let me just make this a little larger. Okay, so what I need to tell the compiler is this. We give you the numbers, right? So we just say, look, this is some kind of base memory address. And to make things simple, we make it A0, just 0, right? We also provide how far. Somehow we provide this crazy number, 3, 5, 6, 7, 7, 8, whatever that number might be, far away from 0. Right? But we also for this program to work, we have to specify this set of parentheses, character, and asterisk. And this says that we need to tell the CPU that the asterisk is pronounced as pointer. And of course, this is a pointer to a character. What's going on here? It appears that, remember, when we declare variables, we always say, oh, it's an integer, it's a double, it's a character, it's a Boolean data type. We provide specific data types. And if you were reading the book or researching the topic, you know that we need to recognize the data types. Those fundamental data types are not artificially invented. They're part of the CPU architecture. So in order for the CPU to extract a value from memory, we have to provide the data type. CPU knows how to extract a character out of memory. CPU knows how to extract an integer out of memory. So part of the internal instruction set, which will be using this type of memory access, is doing, we have to specify that this is actually a character that we want to display. All right, so let's give it a try. So let's rebuild this, right? So all I added to my code is this part. I said that this entire crazy thing I'm trying to do is an attempt to use memory address, right, which is offset, and use it as a pointer to a character. This memory address points to address of a character and not an integer and not a double. So this time everything compiles, and I'm going to say run it, right? Run it. And it says, look, this hello, I told you, anytime there is a string literal like this, its characters with alongside with its zero terminating character, which is appended automatically, is stored in global read-only memory. And I found a really strange way like this to display it as an integer number, and it just happens to be 4644900, which is crazy number, right? So enter an offset I will just simply double click this, hit enter, and paste this in back in, and say here, right? And so it says the character is H. So yes, indeed, it was able to go right back to this memory, which is in global read-only memory, find this character H, and I apologize for displaying press any key to continue on the next line, but you can see that it did extract the character, and this was very much expected. So let's do another, so let's display a new line to make this look nicer, like this. Save that. Build it, and just run it again just to see what's going on. So I'll just, you can press F8 to run it again. So this memory address shows character H. If I press F8 to run it again, and if I enter the address of the next character, which in my expectation is 901, look what it does. It says, yes, the character is E. So I know we're running out of time, but let me modify this program before we exit today's session. I would like to give you another version of this function, which I think will be much cleaner, and we are going to use multi-line comment for this. I'll just preserve what I have in case we need to refer back to it. So this time, I'll modify my program and make it like this. Instead of saying, look, there is memory, there is an offset, and I want to use this memory offset combination as pointer to character, what I can do is that not, you know how I can create variables like x, y, z right here. So those x, y, z's can be populated not just with values in memory, but they also can be populated with these addresses. So that's what we're going to do right now. So it's pretty simple. I can say character offset and use this character offset as a variable type. And I think this is pretty much where I would like to wrap up today, because we've covered some really strange code. So you can, the matter of fact is that hello, which is a string of characters, returns back the address of the first character. Okay, and this the address of the first character will be saved in offset, which is the variable, right? And the type of this variable is pointer to character. And so basically this will give us a much simpler version of what we're trying to do here. For example, we can now say that std cout, right? So if I wanted to display the value of character E, I can use my offset, right? I guess I can use the memory is 0, right? I can use this offset, say +1, and that should pretty much print character E in my view. So I know we're kind of running out of time, and we will do it again, but let me just press F8 to run this again, and here it is, right? So I will show you in the future, next week, basically. We're going to discuss pointers, we're going to discuss arrays, we're going to discuss more of these literal strings and everything related to this topic. So hopefully I sparked your interest today, because these are some really strange methods of going directly to hardware. And you see that some of these experiments really work. So this is to be continued. Unfortunately, today ran out of time. So anyway, till next time. Thank you very much.